Welcome to this video on industrial fire engineering. We will be covering detailed calculations for oil tank fire suppression, focusing on the volumes of foam and water required. Our calculation fundamentals follow a rigorous mathematical approach based on NFPA 11 and NFPA 15 standards, ensuring compliance and effectiveness in fire safety planning. The universal formula, $V_C equals AGDOTR CDOTT CDOTC determines the total foam concentrate needed. This involves analyzing four variables: surface area, application rate, discharge time, and proportioning rate. For fixed roof tanks with full surface fires, the high demand requires 100% surface coverage. Suppression uses fixed foam chambers or subsurface injection at a standard rate of 4.1 L per minute per square meter for 60 minutes. Let's consider an example of a 50-meter fixed roof tank. The calculations detail the steps to determine the required burning surface area, foam solution, and the total water needed, which is 468,394 liters. Floating roof tanks require rim seal protection, where the fire is localized to the annular seal area, typically less than 10% of the total surface area. However, the high intensity increases the application rate to 12.2 L per minute per square meter. For an 80-meter diameter floating roof tank, the foam concentrate needed is only 1,100 liters. This is approximately 93% less foam than what is required for a full-surface fire. Exposure cooling and radiant heat mitigation are critical to prevent structural failure in adjacent tanks. Water is applied at 4.1 L per minute per square meter to the shell surfaces within a 1.5 times tank diameter distance, covering the facing side. The fire water demand curve shows that water demand is maximum during the combined foam attack and the initial phase of exposure cooling. Cooling operations may continue for several hours after foam stops. A logistical comparison highlights the huge difference in foam concentrate. A full-surface fixed-roof fire requires approximately 14,486 liters, necessitating 4 massive foam tenders, while a floating roof seal fire requires only 1,098 liters, manageable by a single rapid response vehicle. In summary, the strategic engineering process involves 3 steps: identifying the tank type and risk area, determining the solution flow rate based on NFPA density, and surcharging resources for shell cooling of all local exposures. Thank you for watching this video on fire safety engineering and infrastructure planning. Please reference the NFPA 11 standard for low, medium, and high expansion foam for further information. These are the sources used for the images in this video.